All right, this is AP/BC Calculus. We're doing Unit 9, Section 6. This is a BC only topic. We are talking about solving motion problems using parametric and vector valued functions. So let's just jump right on in. All right, so let's talk about particle motion. So particle motion with parametrically defined curves. We know that when we were dealing with one dimension before, we would often have our position be x of t or y of t or h of t for height or s of t for position inexplicably, whatevs. Here, x of t is going to be the first coordinate in our vector valued function, and you'll notice that I deferred to using the pointy brackets. You could do all of this with ij notation. It's the same concept. It's just easier and more concise to use these pointy brackets. So x of t comma y of t is the position on the x-axis and on the y-axis, right? Horizontal and vertical position. The x prime of t, y prime of t would be the velocity in the x direction horizontally and the y direction vertically, right? Speed would be the magnitude of the vector, which is the square root of x prime of t squared plus y prime of t squared, or you'll see it as the square root of dx dt quantity squared plus dy dt quantity squared. Acceleration is the second derivative with respect to t of that position, right? So x double prime of t, y double prime of t. And again, each component is specifically for that direction, right? The x-axis or the y-axis, horizontal, vertical, etc. The total distance is the integral of the speed, right? From, let's say, t is a to t is b. But look what that is. That's just the arc length formula. The total distance is integrating speed, which totally makes sense, but it's also just the arc length, which also makes sense because if this is your curve, right? Sorry, that's not the pen. If this is your curve and you're trying to figure out how far like the little car traveled on the curve, that's totally just the arc length, which makes a lot of sense. Let's also talk about some important words and phrases that you need to know what they mean. So we know that at rest, when we did old school particle motion in one dimension, at rest meant velocity equals 0, right? But here we have two velocities. We have the x direction velocity, which is x prime of t, and we have the y direction velocity, which is y prime of t. We need both of them to be 0 because if only one of them is 0, right? So now that we're moving in two dimensions, if y prime is 0, I could still be running back and forth like a crazy person, but I'm not going up and down. Well, I'm not at rest. I'm like flipping out, going horizontally left and right, et cetera, et cetera. Similarly, if x prime is 0, that means I'm not moving left or right, but I could be jumping up and down like a crazy person, right? So in order to be at rest, I need both x prime of t and y prime of t to be 0. In terms of moving right, left, up, and down, they mean the same things they've always meant. Dx dt, or x prime of t, is greater than 0, means that in the horizontal direction I am moving positively, which means right. Dx dt is less than 0, means horizontally I am moving negatively, which is left. Dy dt is greater than 0, or y prime of t is greater than 0, means moving up, right? Positive in the y direction. And dy dt, or y prime of t, is negative, means moving down. Position graphs have a tangent, right? A position graph has a vertical tangent when x prime of t is 0, but y prime of t is not, right? We've seen this before. It's the same idea as what we saw when we did parametric curves. It's just now sometimes the connotation is talking about the position graph. A position graph is a horizontal tangent when y prime of t, the top of dy dx, is 0, but x prime of t is not. And the slope of a curve, if you're asked, is still dy dx, just like it's always been. So let's go ahead and get started. A particle moves along a curve in the xy plane with position x of t, y of t, for any t that's not 0. And you can see why, because in my problem here, there's a t in the denominator. So what is the acceleration vector a of t? Well, that means I'm going to have to differentiate twice, right? So v of t, right, v of t is going to be essentially x prime of t, right, comma y prime of t. Well, I can go ahead and find those two derivatives, right? So this is going to be a 12t squared minus a 10t, right? And this one is going to be, so remember that this is actually a 10 minus 4t to the negative first. So it's going to become the 10 is going to go away, and it's going to become a positive 4t to the negative second, or just a 4 over t squared, right? That means that my a of t is going to be the derivative again, right? X double prime of t, which would be 24t minus 10, right? And y double prime of t, remember that this is actually a 4y to the a 4t to the negative second, so that'd be a negative 8 t to the negative third, or a negative 8 over t cubed, right? So that's my first answer. What is a of t? And I could have written it either in this vector notation or in ij notation. I just don't particularly care for ij notation. And then a of 2 is going to be what happens when I plug a 2 in, right? So that's going to be a 48 minus a 10, and then a negative 8 over an 8. So I get that a of 2 is a 38 comma negative 1. And that's it. So those are the two parts of that problem. Again, I find that parametric motion and these vector valued functions are fairly intuitive. So again, this is the same situation. I did give the caveat that t can't be 0, right? So again, you're going to find acceleration, right? So the velocity vector is going to be x prime of t, which would be 2t plus 5. And then because this is a negative 10t to the negative first, this is going to be plus a 10t to the negative second. And I'm actually going to leave it that way because it was sort of a mistake on the last one that I didn't. It's just much easier. So that's my x prime of t. Here's my y prime of t, right? That's going to be a 3t squared minus 3, right? And so then my acceleration is going to be what happens if I differentiate again. So this is going to be a 2 minus a 20t to the negative third, and this is just going to be a 6t. So that's fine. If you want to put the t to the negative third on the bottom, you certainly can, but you don't have to. My a of 1 is going to be a 2 minus a 20 over a 1 cubed, and a 6 times a 1. So it seems like I get 2 minus 20, so negative 18, and a 6. And that's it. That's my a of 1, right? So those are the two questions I was asked, and there are my two answers. All right. A particle is moving along a curve in an xy plane such that this is its acceleration. So a of t is, and this is not meant to be a greater than or less than. It was just the easiest way to do pointy brackets in this particular software. So, don't read too much into it, okay? So this is my acceleration. Given that the velocity at 0 is negative 2, negative 5, what t values is the particle at rest? So in order to find when the particle is at rest, right, so our job is to sort of parse what's being asked. We're being asked when are both x prime of t equal to 0 and y prime of t equal to 0. That's what I'm being asked, right? That's what I need to find. That's the question I'm being asked to answer. So in order to do that, I really need to find both components of the velocity. So v of t, right? V of t is going to be what happens when I integrate this. So I'm going to get t squared minus t plus some constant c. And I'm going to get t squared minus 4t plus some other constant. So I use c sub 1 and c sub 2. I'm then going to use that I know the velocity at 0 is negative 2, negative 5, right? So that means that when I plug in 0, I should get 0 plus c sub 1 is a negative 2. Okay, that's cool. C sub 1 is a negative 2. And 0 plus c sub 2 is a negative 5. Cool, c sub 2 is a negative 5. So seems to me that my velocity is t squared minus t minus 2, comma, t squared minus 4t minus 5. Well, I need to find when these things are equal to 0, and I want the time or times when they are both equal to 0, right? So x prime of t equals 0 when t squared minus t minus 2 is 0. That factors into a t minus 2 times a t plus 1. So the two times I get are t is 2, and t is negative 1. Right? Y prime of t equals 0 is going to happen when t squared minus 4t minus 5 is 0. Well, that factors into a t minus 5 and a t plus 1. So t is 5 and t is negative 1. Well, that means that the only time that this thing is at rest, so the only time that this thing is at rest is at t equals negative 1. And again, the logic behind that is at t equals 2, right? At t equals 2, there's no horizontal velocity, but there is vertical velocity. So the thing's going up and down, up and down, up and down. That's what's happening at 2, right? It's just jumping up and down, right? So at 2. And at 5, there's no horizontal velocity, or I'm sorry, there's no vertical velocity, but there is a horizontal velocity. So it's going back and forth, back and forth, back and forth, right? So the only time it's at rest are when both x prime of t and y prime of t are 0. All right, so let's go ahead and do another one. So again, a particle is moving along this curve, and we are given the acceleration. So a of t is the vector 4t plus 1, comma 4t plus 3. We're given the velocity at t is 1, so that's v of 1 is a negative 3 and a negative 4, right? And we are asked, and this is the important thing, for what t value or t values is the particle at rest. Remember that what that's asking is you want when both x prime of t and y prime of t equal 0, right? They both have to be 0. That's important. So let's go ahead and find v of t, because that's where we're going to start, right? So my v of t is going to be the antiderivative of acceleration. So I'm going to get a 2t squared plus t plus some constant c sub 1. And for the y component, I'm going to get a 2t squared plus 3t plus some constant c sub 2. I'm now going to use this negative 3 and 4 when I plug in t as 1 to find the values. So when I plug in t as 1, I'm going to get 2 plus 1 plus c sub 1 is apparently a negative 3. So c sub 1 is a negative 6. When I plug in here, I'm going to get 2 plus 3 plus c sub 2 is a negative 4. So apparently my c sub 2 is a negative 9. Cool. So now I have the velocity. Right? The velocity is 2t squared plus t minus 6 and 2t squared plus 3t minus 9. Right? And I want to know when this thing, which is x prime of t, and when this thing, which is y prime of t, when those equal 0. Right? So let's go ahead and factor some stuff. So x prime of t is going to be 0 when 2t squared plus t minus 6 is 0. Right? When I factor this, I know the front seats have to be a 2t and a t. Since it's a non-calculator section, it's pretty likely it factors. I'm guessing that this is either a 1 and a 6 or a 2 and a 3. So it is usually the middle set of numbers, meaning it's usually the 2 and the 3. And I know that since there's no GCF in this original expression, I can't put a 2 in here because that would create a GCF. So I suggest that it is probably a 2 over here and a 3 here. I know from the negative that they have to have opposite signs. So since I want to net a positive 1, I want to make a positive 4t and a negative 3t. And sure enough, if I FOIL, 2t squared, outer is a 4t, inner is a negative 3t. That's my regular t, and then a negative 6. So I get that t is 3/2 or negative 2, right? If I do the same thing for y prime of t, and it's pretty likely that one of these values is gonna overlap, right? That's kind of the idea of the problem. Again, I'm pretty sure it's going to factor into a 2t and a t, right? Because it's probably going to factor. I look at the 9, and it's either a 1 and a 9 or it's a 3 and a 3, but it's almost always the middle set of numbers, and I see that they have opposite signs. So as soon as I realize they're probably both 3's, I look and say, hey, it's really likely that this factor is going to be the same factor. So let's try this as the minus and this as the plus. And sure enough, I get 2t squared, which is right, a plus 6t and a minus 3t. Well, that's a positive 3t, and a minus 9. So I get t is 3/2 and t is negative 3. Well, that means that the time when this thing is at rest is at the time when both of those are true. So we are at rest when t is 3/2. And if there are units, you should use units, but I don't think there were any units given in the problem. All right. So E3, non-calculator again. A particle moves along a curve in the xy plane with position x of t, y of t. We're given the position. What is the speed of the particle at t is 2. So speed of the particle, right, is the square root of x prime of t quantity squared plus y prime of t quantity squared. So that's the first thing you want to communicate. You want to communicate that this is x prime of 2 quantity squared plus y prime of 2 quantity squared. Because even if something goes wrong, even if you plug in wrong or you find the wrong value, because you've already communicated this, you're probably getting a good part of the credit just for communicating that. So I need to go ahead and find x prime of t. So x prime of t, the derivative of t to the 1/2 should be 1/2 t to the negative 1/2, or as we've seen it a bunch of times, 1 over 2 root t. Y prime of t should just be a 2t. So now that I know those, I say, okay, cool. This is if I want x prime of 2, right? So x prime of 2 should be a 1 over 2 root 2, right? And y prime of 2, kind of out of room, but y prime of 2 should be a 2 times 2 or a 4, right? So I know that this is a 1 over 2 root 2 quantity squared plus a 4 squared, right, inside that square root. When I square the 1 over 2 root 2, right, the 1 gets squared, doesn't do much. The 2 gets squared, that's a 4, and the root 2 gets squared, and that means that's a 2. So I get that this is a 1 over 4 times 2 plus a 16, right? So this is a 1/8 plus a 16. If you want to get 16 as a common denominator with 8, it should be a $1.28. So I get that this is the square root of a 1 plus a 128 all over 8, or a root 129 over 8. And if you want to simplify it, you can. That's where I'd stop. You could certainly try to make it look nicer. Like you could make this a 2 root 2 on the bottom, and then you could rationalize, but like why, right? So you could rationalize if you want. Like you could say, hey, that's a root 129 times a root 2 over a 4, because 2 times 2, right? I just don't see a reason, right? Because that'd be a 258, right? This is not making anybody's life better. Like there's no reason to do that. So this is where I would stop. Same idea, right? Particle in the xy plane, we have x of t and y of t. What's the speed, right? So again at 2, right? So you need x prime of t, which is going to be a 3t squared. You're going to need x prime of 2, which is going to be a 3 times a 4, so a 12, right? You're going to need y prime of t. So remember that this is actually a 6t to the negative first, right? So that's going to be a negative 6t to the negative second, which means y prime of 2 is going to be a negative 6/4, or if you like it better, a negative 3/2, right? So my speed, right? So the speed at t equals 2 is going to be given by the square root of x prime of 2 quantity squared plus y prime of 2 quantity squared. So that's going to be a 144 plus a 9/4. And again, if you want to clean it up, I mean, like that's not a wrong answer. There's a good chance you might have to clean it up more than that. Let's see, that's a 400 and a $1.60. So it's a 560 and then a 16, so 556, I think. Let's find out. I'm going to cheat a little, even though it's non-calculator because I'm feeling lazy. Hey, 576. I think that's what I said. So I'm going to get that this is the square root of a 576, sorry, it's a 6, plus 9 all over a 4, right? So I get that this is the square root of a 585 on top of a 2 that's not in the root. And I don't really think that you're going to have anything that's, this is technically a right answer. In general, in the AP, you can get the extra point just for getting the right numerical answer, even if you didn't clean it up. All right, so now we're going to do a calculator one. So a particle moves along the curve such that its position is x of t and y of t. That means that these two things are the velocity, right? Because these are the derivatives. And you're asked, what's the speed? Well, you were just given the velocity, right? So if you want the speed of the particle at t is 1, that's going to be the square root of this dx dt evaluated at 1, right? So essentially the natural log of 1 plus 1 quantity squared plus 1 sine of e to the 1 quantity squared, right? That's it. So, and the reason it's calculator section is because you're going to type that in a calculator, right? So I'm going to put that this is the square root of, in parentheses, the natural log of 2 quantity squared, because that's what the 1 plus 1 would be, right? Sorry, natural log whole quantity squared, plus, hang on, that's the log, yep, okay, plus the sine, so in parentheses I want the sine of e, right, oh, my bad, sine of e, close the sine, close the whole thing and square it, and then close the whole root, and there you go. So I get that the speed is approximately 0.805 or 6. And again, no units were given, so I don't have to give units. Don't invent units that weren't provided. Same concept. Again, position is x and y, so that makes these velocity, right? So your speed is going to be given by the square root of cosine of 9 quantity squared, right? Because it would be t squared, plus the natural log of 9 plus 3 whole quantity squared. And then I'm going to type it in a calculator, right? So a square root of, in parentheses, the cosine of 9. Do make sure you're in radian mode, because boy, would that stink. Plus the natural log of 12. So the natural log, and then in parentheses 12. Close the log, close the whole thing, square it, and then close the root. So I get 2.646 or 7. Again, that's mostly calculator, not because the calculator's doing any calculus, but just because you're not expected to find that by hand. If you didn't have a calculator on something like that, you would write this work and say, hey, cool, that's the best I can do. I don't have a calculator. All right, So here again, we have position x comma y, and yet we're given velocity, right? These are velocity, okay? So when we're asked total distance, right, the total distance from 0 to 3 is going to be, so the total distance is going to be the integral from 0 to 3 of that speed, right? So dx dt, quantity squared, plus dy dt, quantity squared, with respect to t. And then I make my calculator do all the work, and they called them dx dt and dy dt, so I can just write that. They gave me that information, so I can just write that exactly as is. If you feel edgy or upset about that, you can definitely write the function out. So I'm going to make my calculator do the heavy lifting. I'm going to go ahead and put in that this is the natural log of t to the 4th plus 1. Right? Oh, yep, that's my x. Yep. And then t sine of e to the t, and close that. All right, cool. So I'm going to quit out of here, right? And then I'm going to go ahead and do math 9, right? What I'm integrating is the square root of, so I don't actually need the extra parentheses. That's the advantage to using the variable. I go to parametric. So x1t squared, right? Because that's what I put in as x1t, plus vars over to parametric and y2, right? Or sorry, y1t squared, close the root, comma, with respect to x, but with respect to t, from 0 to 3. And hit enter. And there you have it. So my total distance. Again, if no units were given, don't invent units. If there were units, if it was in meters, then put meters, right? Same idea, total distance, right? So your job is going to be to write what the integral says, and then because it's a calculator section, the calculator does the work. So just to be clear, this is the part that was me, right? This was the part that was my calculator. I'm allowed to use the notation that's provided to me. So they called them dx dt and dy dt, so I called them dx dt and dy dt, and that's totally fine. All right, cool. So same idea, you're going to have to do the heavy lifting, right? You need to say that the total distance is from 1 to 7, the square root of, and you can either call it dx dt and dy dt because that's what it was called in the problem, right? Or notice, though, that's because they're different things, right? If you were ever given two functions that were both called y, you can't just call them both y in the problem. You'd have to write them out. But here, they're very two distinct, clear, different equations with different names. So this is the part you have to do. And then your calculator does the rest of the work, right? That's your calculator, and you just have to know how to enter it in your calculator. So basically, I'm just going to go ahead and change the functions to match the ones we have now. So this is going to be the natural log of a t squared plus 3. All right, so that looks right. We'll quit out of this. And then I'm going to hit second enter because I already did this, right? And the only thing I really need to change are the bounds because I already changed the function. So now it's from 1 to 7. And I hit enter. And we get that the total distance is the same as the arc length, which is 17.577. All right. Okay, back to a non-calculator. So the position of a particle traveling in the xy plane is given by x of t and y of t. Set up but do not integrate. So this is a classic example of something where they just want to see that you understand it. An integral expression for the total distance. So to do this, you're going to need x prime of t. Now in this situation, you're going to have to show that you know how to find x prime of t, right? So the derivative of cosine is a negative sign, and then I'm going to have to multiply by that 5 for the chain rule. So I'm going to get negative 5 sine of 5t, right? My y prime of t is going to be a 3t squared, right? So I have to do this. This is me, right? I also have to communicate that the total distance is going to be the integral from 1 to 10 of the square root of, and then I need to use those things. So negative 5 sine of 5t quantity squared plus 3t squared quantity squared with respect to t. So that's what I have to do, right? If it's a calculator section, my calculator would do the crunching of the numbers, right? But I have to do these things in my brain. Notice that I wasn't given x prime of t and y prime of t. I had to find them, so I should write what they are, right? I need to clarify that that's what they are. All right, you go ahead and try the same thing. Again, you're going to set up but not integrate an integral expression for the total distance. So you need to find x prime of t. It's going to be 1 over the stuff times the derivative of the stuff. So you're probably going to write it as a 2t over this t squared plus 3, right? Your y prime of t is going to be a 6t t plus 5. And so then your job is to write that the total distance is going to be the integral from 2 to 15 of the square root of this 2t over t squared plus 3 quantity squared. Don't clean it up, don't simplify, right? A 6t plus 5 quantity squared with respect to t, right? So that's what you need to get to. Now, if you hadn't done the step of writing these, if you just did these in your head and you put them in the expression, that's not wrong, but I would say it's a safer bet to make sure that you include them. All right, a particle moves along the graph of y equals sine 2x in such a way that the x component of the acceleration is always 5. At time t equals 0, the particle is at point pi over 4 comma 1, and the velocity of the velocity vector of the particle is 0, 0. Okay. Write an expression for the x and y coordinates of the position at time t. So what I'm being asked to find, right? I'm being asked to find x of t, comma y of t. Right? That's the ask. That's what I'm being asked to find. And I found this to be a pretty clever problem when I stumbled upon it. So I wrote a similar problem. It wasn't this exact problem, but I wrote a similar problem because I think this is pretty clever. And it's kind of a tricky problem, which is why I'm saving it for later in the video. So here's what we know. The x component of the acceleration is always 5. Okay, so let's start there. X double prime of t is always 5. Cool. That gives me enough information to find x prime of t. X prime of t is a 5t plus some constant. Because I know that that the velocity at time t is 0, the velocity is 0, 0, right? So I know that at t equals 0, I know two things. I know that v of 0 is 0, 0, and I know that the position, right, whatever the position is, so the position, and I know that x of 0 is a pi over 4, and y of 0 is a 1, right? That's what I know because I have those two values. So this is initial conditions that I was given, right? If I read this line carefully, that's what I find out, right? Those two lines right there. So I'm now going to use this information to find that c. Now you might be saying, hey, but Hogan, what are we supposed to do about y? We don't know anything about y yet. Well, we're going to deal with that in a minute. So, so my x prime of 0 is apparently 0. Well, that's 5 times 0 plus c sub 1, so it seems my c sub 1 is just 0, which seems a little anticlimactic sometimes because you're probably, like if you forgot to find c, you would just naturally get this answer. But keep in mind that the AP is looking for you to find c, and if you don't include c, if you just skip that step, they're going to take off the points. Okay, so now I can go one step farther, and I can go ahead and find x of t, right? So x of t is going to be 5 halves t squared plus this thing I'm going to just go ahead and call c sub 2. Well, I know that x of 0 is apparently a pi over 4. So what that means, right, if x of 0 is a pi over 4, so I'm going to use that the x of 0 is a pi over 4 to say, cool, when I plug in 0, I get pi over 4 equals 0 plus c sub 2. C sub 2 must be a pi over 4. Cool. So I now, after all that work, I have an equation for x of t. I'm half done with the problem. 5 halves t squared plus pi over 4. That's my equation for x. Okay, so this is half of my answer. And this is kind of where I ran into a wall when I was doing this, and I had this moment of panic when I saw a problem that was like this, and it wasn't this exact problem. And then I realized that there's this other piece of information that they gave me that we've been ignoring. The particle moves along the curve y equals sine 2x. Well, if it's on the curve y equals sine of 2x, and if x is this expression, then y of t is just what happens if I oh, I'm a little bit low on space. It's just what happens if I replace this x, right? I know that x is this expression. So if I replace this x with that expression, that'll be my y of t, and it's actually not as tricky as it seems. So I recognize that I can make y of t be the sine of 2 times this expression, 5 halves t squared plus pi over 4. And you could leave it like that, and that's totally fine if you want. Notice that I kind of skipped the end. I never had to find the c values for any of the information, right? I never had to find a plus c, right, for any of that information. So Yep, that's perfect. Sorry, just checking. Yep, we're all good. My brain just did a crazy thing and turned pi over 4 times 2 into pi over 8, and that's not what it is, and then I had a panic moment, but there's my y value. So my position, right, my position is given by these two quantities, right? And I can just label them like this, right? I can say x of t is 5 halves t squared plus pi over 4. And I can clean up y of t if I want. I can either leave it the way it looks here, or I could distribute the 2 and make this the sine of 5t squared plus pi over 2. That's fine too, like that. Or you could write it in vector notation like this, right? 5 halves t squared plus pi over 4 and sine of, and again, you could use this version if you wanted. I just cleaned it up a little bit. All right, and so that's kind of the trick. And so the first time I saw this problem, I got all the way through the x stuff and then had a moment where I thought, well, how am I supposed to find the other half, right? But then if you have that mental leap that they gave you that other information for a reason, it's not so bad. All right, so you're going to try the same concept, right? A particle moves along the graph of y equals e to the 3x, such that the x component of the acceleration is always 4 at time t equals 0. We know that the particle is at the point 2 comma e to the 6th, and the velocity vector of the particle is 0, 0. Write the expression for the position of x and y. So it's the same concept. So let's go ahead and walk through that. So here's what we know. The x component of the acceleration is always 4. So x double prime of t is always 4. That means x prime of t is a 4t plus some constant. Since we know that when t is, like, we know that v of 0 is a 0, 0. So that means x prime of 0 is a 0, which means my c sub 1 is also a 0. So yet again, turns out that you don't really need that plus c, but we should not assume that generally, right? If I do the antiderivative again, I know that x of t is a 2t squared plus some other constant. And I was given that when I plug in 0, my position in the x direction is a 2. So if I plug in 0, x of 0 is a 0 plus c sub 2, and it's apparently a 2. So my c sub 2 is a 2. That means that I now have the x position. It's 2t squared plus 2. So once I know that half, right, that half's done. Well, now I go back up here, all the way up, and I say, oh, look, y equals e to the 3x. That's the curve this thing's on. So my y of t is an e to the 3, and then in place of the x, I think it was a 2t squared plus 2. So 2t squared plus 2. And that should be my y. Now, if you want to clean it up a little, you could distribute that 3 to the exponent. You could make this an e to the 6t squared plus 6 if that's what you want. It doesn't really matter. And then just a quick double check, if you plug in 0, you should get e to the 6, and sure enough you do, right? So that's my answer. So those are my two, these two together are my answer. All right. Again, kind of a clever problem. All right, so let's do 2 last problems. A particle moves in the xy plane such that its position is given here. At the moment when the particle travels through the point 6, 2, describe both the horizontal and vertical motion of the particle. So usually what this phrase means is they usually want you to describe whether the motion is towards or away from. So towards or away from an axis, right? So for the vertical motion, they'll want you to describe if the particle is moving down towards the axis or up away from the axis or up towards the axis. So that's kind of the idea. So let's go ahead and walk through this. So in order to describe the motion, you basically need 2 pieces of information. So one, where are you, right? Where is the particle, right? So that's the position. And 2, which way are you moving? And we're going to address this again later in another video. In fact, when we talk a little bit more about polar, I believe is when I include it, because you'll hear this question in polar motion too. But sort of the analogy for this is if I asked you, if I said, if you told me that you're walking east and I said, are you walking towards or away from Broad Street? Or I'm sorry, if I knew you were walking east and I was trying to figure out if you're moving towards or away from Broad Street, I would have to know both that you're walking east. I'd have to know which side of Broad Street you're standing on, right? If you're standing at 17th, right, and walking east, so 17th and Norris, let's say, and walking east on, then you're walking towards Broad Street. But if you're standing at 12th and Norris and walking east, well, then you're walking away from Broad Street. So in order to know whether you're moving towards or away from a location, I need to know both your physical position and which direction you're moving, right? So that's basically what we're going to do. So the first thing we can find is our position. So in the horizontal direction, we'll do two things. We'll do horizontal and we'll do vertical, and I'm just going to kind of organize these as two separate pieces of information. I'm going to need two things. I'm going to need position, right, and I'm going to need velocity. So those are the two pieces of information I need for both. So because of that, I'm going to go ahead and find my x prime of t to be an 8t and my y prime of t to be a negative 3. So what that means, so we are asked at the moment when the particle travels through 6, 2. Well, I kind of need to find that moment, right? So I need to know at the moment when the particle travels through the point 6, 2. So in order to find that moment, right, I need this time. I'm being asked, when is x of t equal to 6? So 4t squared minus 10 equals 6. 4t squared is 16. T squared is a 4. So my t is either plus or minus 2. But I also need the moment when the y value is equal to 2. So 8 minus 3t is a 2. Negative 3t is a negative 6. So we're looking at t is 2. So the time we're talking about is t is 2. Okay? So all of these questions, right, the question I was asked in green here, where it said at the time when this thing happens, that's worth noting that that's apparently at time t equals 2, right? So that's the time we're talking about here. So I can find, I already know what x of 2 is. X of 2 is a 6, and y of 2 is a 2 because we already figured out that we were given that information, right? But x prime of 2 is going to be a 16, because 8 times 2, and y prime of 2 is going to be a negative 3. So if we're asked to describe this motion, what's happening here is 6 is a positive value, so it's to the so this is starting to the right of the y-axis, and this says I'm moving right. So what's happening in the horizontal direction is the particle is right of the y-axis and moving farther right, meaning away from the y-axis. So that's what's happening horizontally. Vertically, this, right, y of 2 is 2. Since that 2 is a positive value, this means above the x-axis, right? But this means moving down. So the particle is above the x-axis and moving downward, meaning it's moving towards the x-axis. And that's usually about what they want, right? That's pretty much the explanation. Sometimes they'll come out and flat out ask that question. They'll say, is the particle moving towards or away from an axis or some other point? But that's kind of the idea. They could ask you about some random line. They could say, is the particle moving towards or away from the line x equals 7? But to do that, then you would just have to determine where the particle is relative to 7. It would be a really weird choice to ask that, but it's possible if they were trying to think outside the box. All right, let's do one last practice problem. So same question, same concept. At the moment when a particle, so these are my position. At the moment when the position of the particle is negative 7, 9, we might as well just go ahead and find that time first, right? So you want to find the time when they're talking about. So if I go ahead and plug in negative 7 equals 5 plus 6t, that's a negative 12 is 6t. I get t is negative 2. And I can solve the other one, but I'm going to get the same answer, right? Negative 9 equals t cubed minus 1. Negative 8 is t cubed. Yep, my t is negative 2. So that's the time we're talking about. Okay, so that's when, right? And then I'm gonna need to find x prime of t, right? X prime of t is a 6, and I'm gonna need to find y prime of t, and that's gonna be a 3t squared. So when we talk about my horizontal motion, and we talk about my vertical motion, here's what I know, right? So all of this is at t equals -2, right? I know that x of -2 is a -7 because it was given. I know that y of -2 is a -9, right, because that was given. And then I can find x prime of -2. It's a 6 because x prime is always a 6. And y prime of -2 is going to be a 12. So here's what I know. So since x of -2 is negative, this means left of the y-axis, and this is moving right. So when I answer, the particle is left of the y-axis and moving right, which means if you're left of the y-axis and moving towards the right, that's towards the y-axis. And you'll notice that it really seems to have to do with the opposite signs, right? A negative means that you're left, but moving right if you have a positive. So when the signs are opposite, it basically means that you're moving towards something because you are to the left of the axis and moving right, or you are to the right of the axis and moving left. And if the signs are the same, then you're generally moving away because you're already to the right and you're moving farther to the right, or you're already to the left and you're moving farther left. So here, the -9 means that we are below the x-axis, right? The 12 means that we are moving up. And sure enough, those opposite signs say that we're moving towards the axis, right? Because the particle is below the x-axis and moving up, which means towards the x-axis, right? Moving up, so towards the x-axis. And that's it for this video.